Okay, so welcome back. So let's dive into our fourth objective, gaining knowledge about the data and the problem. Now, in our last video, we sort of outlined what this concept of supervised machine learning was all about, but we didn't talk about the types of problems that you can actually solve with supervised machine learning. And since we're getting ready to solve our first problem, let's kind of talk about that just quickly. So basically, there are two types of problems that supervised machine learning will help you solve. And it all goes down to breaking down your business problem and understanding the nature of the inputs and the outcomes or the outputs, right? We've already identified what those are. We know our inputs are our first six numerical weather-related variables, and our outcome, in this case, we call this the Y, is actually solar radiation. So based on what we know about this problem, we have to see, is what we're trying to predict, in this case solar radiation, is it a continuous numeric variable like solar radiation is, right? Changes over time. Or is it something that's discrete like a category like small, medium, and large, or sunny, cloudy, rainy, stormy, different categories, right? So these are the two basic types of problems that supervised machine learning will help us solve. If our dependent variable is continuous and numeric like ours is, it's called a regression problem. If it's a category and discrete, it's called a classification problem. And we need to get into that a little bit deeper in subsequent videos, but just know today we're working on a regression problem. We've already identified our outcomes and our inputs, and we are ready to go. So it's going to take just a few minutes, walk you through what we're bringing in. I've purposely not run any of these cells in this particular video. In the next video, you'll see that they'll have all been interpreted, and you'll see the results, but my intention is to have you work through these before you actually get to the next video, or it wouldn't be a learn by doing exercise. So you can see we have a few data science, basic data science-y, not related to data science, but we're going to be using them for that. NumPy, Pandas, Matplotlib, and Seaborn, obviously some of those for plotting, working with files and numbers. We've got some modules here specifically from scikit-learn that we're going to use for our modeling, for splitting our data, for our assessing our data, and then we've got a few other helpers and some things that we need to bring in for plotting itself. So that's our imports. So the first thing we're going to do, bring in our data. I've included it with this particular notebook. You can feel free to download it and replicate it on your end. It's called whole year CSV. We're assigning that to a variable called solar. We're dropping any duplicate rows. We don't want any duplicate information, or our algorithm's gonna, depending on the algorithm we use, may use that more than once. We don't need to use the wind speed column. We know from our domain knowledge of this area, that's not gonna be useful for this exercise. And then after we get finished with all this, we're gonna take a quick sample of our data, of our solar data frame, just to make sure that everything came out like we need it to. And again, in the next video, I'll go ahead and run these cells so you can see what the output is. So getting into pre-processing, we need to check our data types. We need to make sure we don't have any missing values. We need to convert air temperature from Celsius over to Fahrenheit, because right now it's in Celsius units. And then we're going to do some quick descriptive statistics on all of our numeric data, and then check our correlation. This is really sort of the minimum amount of EDA, exploratory data analytics, that you should do on any type of problem. It's generally much bigger than this. Not only because as data scientists or ML engineers or whatever your applied area is, many times we don't have a lot of domain knowledge about the actual topic that we're working on or the data set that we're working on. So we're using what we can use, which is statistics, to pull that data apart to figure out, what type of algorithm needs to be used on it, what we can and cannot do to the data as far as transformations. We're looking for distributions. We're doing a lot of plotting. I kept it simple here because, again, this is a day zero intro to machine learning, not a day zero intro to statistics or something like that. And again, I haven't ran any of these cells on purpose because I want you looking at these things. We'll pick it up in the next video and kind of show you what the outputs are, which is This one's getting ready to end now. So last but not least, we need to see how our actual inputs are correlated to one another. And if our output is numeric, see how all of our numeric inputs are actually related to our numeric output. In some cases, we may have to get rid of some features. Matter of fact, sometimes in machine learning, you have these massive problems with hundreds and hundreds, sometimes thousands of inputs. And one of the very first things you have to do after cleaning all of your data, you have the large task of minimizing the number of inputs to a problem. Bigger problems aren't always better in machine learning. Yes, more data will help you, but that does not mean more features or more X values. Generally, sort of the rule of thumb is for every additional column that's added to a data set, you can generally hypothesize that your training time, or the time that it's taking the algorithm to actually do its work, will almost double. So we really have to keep an eye on what columns we're using in the X values of this particular problem. We can get a better handle on that by using descriptive statistics, correlation, and a host of other things that we won't get into here. That's sort of the end of pre-processing and what we call exploratory data analytics. Again, I don't want to underemphasize this particular section of ML. I would say this is probably 50% of the work right here, with another 20-25% of the work coming into as cleaning your data, and then the last pieces are probably 20% of actually modeling and telling the story and things of that nature. So I'm going to stop there. I'm going to run these cells, pick back up here in just a few minutes with our fifth objective, and we're going to get into modeling and assessing this problem.